Hello, so here we're going to talk about the properties of the integral, and we're just going to look at five, probably the five most commonly used ones, and these are going to be really helpful because as we evaluate integrals, there's certain tricks that we can do to simplify them to just make that process easier. So this first one here is pretty straightforward, and these aren't necessarily properties you need to memorize. I just want you to make sure you understand the intuition behind them, and they should sort of come naturally to you as you apply them. So here we have the integral from a to b of the function f of x equals c. So we can look at this two different ways. First, we can look at it algebraically, and if we apply the fundamental theorem of calculus part 2, this integral is equal to cx, where cx is the antiderivative of c. And then we evaluate it at b and subtract the value we get when we evaluate it a. So this is just cb minus ca. We factor the c out and get this equal to c times b minus a. So that's our first property. Now we can also look at this graphically, and we'll look at the rest of these properties graphically just because I want to give you a sort of an intuition of why you can trust these properties. So if we look at this, consider this graphically, we have this function f of x equals c. Not a very exciting function, but this is a really simple property. So now we're looking for the integral of this between a and b. So say we had our start point a and b here, and we're looking for the area under this quote curve, even though it's just a straight line, which is shown in the red here. So if you wanted to find that area in the red, this is a pretty simple geometric problem, right? You would just take the width times the height. So our width is going to be b minus a. Our height is going to be c. So our area under the quote curve here is just going to be c times b minus a. So you can see graphically that this matches up with what we got algebraically, c times b minus a. So that's our first property. Second property is with regards to addition. So if we have two functions f of x and g of x, say this is our integral of f of x from a to b, where f of x is this red line here, and that red shaded area is this integral, or the area under that function between a and b. And then suppose this is our g of x function in the blue, and that shaded region is the integral, or the area under that curve between a and b. So if we wanted to add these together, we would get something that looks like this in the purple. So this is the integral of these two added together, and that really is just you could just think of it as the addition of these two functions. So you see the red here, that of course that matches up with this, and now we're just adding on top of that this red area, we're just adding the blue area that we found over here. So really it's just this integral of f of x plus the integral of g of x, and we get back to this in the purple. So but basically what this property says is this area in the purple here is just equal to the area in the red here plus the area in the blue here. All right, we're going to skip down to property 4 now because it's similar, and we're just using subtraction instead of addition here. So say we have our function f of x here, and this blue shaded region represents that integral of it from a to b. And we have our g of x function where the red shaded area represents its integral from a to b. Now if we wanted to subtract this integral of g of x from a to b from the integral of f of x from a to b, we would end up with something that looks kind of like this, where this blue line is our f of x function, and now this red here is sort of what we're subtracting out of our f of x function. We're sort of subtracting out this area here, and we're ended up with kind of what's in the blue, or what's in the eventually what's in the purple here, which would be the integral of quantity f of x minus g of x from a to b. So what basically all this property is saying is this area in the purple is going to be equal to this area in the blue minus this area in the red, which hopefully graphically that should make sense. All right, that's property 4. Now we're going to skip back to property 3, which is the integral of c times our function f of x from a to b. So say this is our function f of x in the blue here, this blue line, and this is our function c times f of x. In this case, c is equal to 3, but you can see we're just multiplying that function, so we're increasing its value by 3 times at each point. Now imagine we want to take that integral of c, quantity c times f of x from a to b. We end up with this green shaded area here. Now what this property basically says is this green shaded area is going to be equal to 3, or c, times the shaded area in the blue. So a way that might help think about this is imagine a Riemann sum. So imagine here we have a Riemann sum approximation, a midpoint 4 rectangle Riemann sum approximation of this integral, which is, we're just adding up the area of each of these 4 rectangles. Now what the property says is that this is equal to c times these the area of these blue rectangles. And so you can imagine that all that we're doing here is we're just multiplying each of these rectangles by 3. So in this case, you see this rectangle has like a height of 1 here, and over here it's got a height of 3 because we just multiplied it by 3. So you can see if you multiply each of these rectangles by the c value, you're going to get the same value you have for c times f of x over here. So hopefully graphically that helps to understand this third property, where you can just kind of take that c outside of the integral. And this ends up being a pretty handy one, because you taking that c outside of the integral just helps to simplify things quite a bit sometimes. And our final property here, property 5, is it's a little bit different. Instead, we have the same function here, f of x, but we're looking at the integral from a to c and c to b here. So we're looking at our limits here. And so say this is our function f of x, and the blue represents the integral of that between a and c. And say we wanted to add the integral between c and b here of that same function f of x. So all this property says, if you add these together, you're just getting sort of this continuous integral from a to b, which is just essentially that blue and the red. So you could think of it as this purple here is just equal to this red plus this blue. So nothing too profound there. Hopefully that makes sense. So in summary, we've talked about these 5 properties of integral, which you will use quite often in evaluating integrals, and I'm sure you'll find them to be quite helpful in simplifying the process of evaluating them.